Welcome friends. In the previous class we have already discussed and understood how the analysis tool pack is installed in MS Excel. Once the analysis tool pack is installed in your MS Excel package, after that you can perform each and every statistical analysis which is available with analysis tool pack of MS Excel. So one by one we will understand, and in today's class we will discuss how this one-way ANOVA is computed, how one-way ANOVA table is constructed, and how interpretations are done by use of one-way ANOVA table. And additionally, we will understand how one-way ANOVA is performed as a statistical analysis by use of analysis tool pack in MS Excel. So you just see, take for example this problem in hand. So friends, today we have taken an example to understand how this one-way ANOVA is computed, and this example is like this. There are three different types of advertisements with three different contents on a brand shown in four different geographies, and the following table is giving information about the per square kilometer recall rate of the brand. State if the difference in impact of the advertisements are significant at alpha is equal to 0.05. Here alpha stands for the level of significance, friends, and here you can see in this table that the per square kilometer recall rate for three different ads. Three different ads means three different ads are having three different types of contents, and it has been given in the first column the add content A, and the second column add content B, and in the third column add content C. And there are four different geographies on in which these advertisements have been shown. And in the table you can see that what is the recall rate, per square kilometer recall rate has been given here. So we have to find out whether the advertisements with these three different contents on the given brand shown in four different geographies have got different significantly different impact. And for this, first of all, we have to formulate the null hypothesis, and the null hypothesis is a statement which has got the highest chance of getting rejected. Since there are three different contents which has been shown in three different advertisements, so obviously from the sample data itself it reveals that there is the impact is different in each of the cases. So if we will formulate a statement just opposite of it and say that there is no significant difference in impact of the different types of ad contents, then this statement will have the highest chance of getting rejected, and this is the most suitable null hypothesis. And the alternative hypothesis is the just the opposite of the null hypothesis, and here I have formulated the alternative hypothesis as there is no significant difference in impact of the different types of ad contents, which is just the opposite of the null hypothesis previously formulated. Now let us go step by step for constructing the ANOVA table. And the step 1 of this one-way ANOVA. Why it is one-way ANOVA? Because there is only one variable, and that variable is about the advertisement, type of advertisement. We are willing to find out the impact of type of advertisements on per square kilometer recall rate here. And here the step number 1 is that we have to obtain the mean of each sample, that is x1 bar, x2 bar, x3 bar, xk bar, where there are k number of samples. Now friends, in this table we have got three different samples since there are three different advertisements. So x1 bar will be equal to the sum of the values given in column 1 divided by the number of items in column number 1, and that will be 6 plus 7 plus 3 plus 8 divided 4 is equal to 6. Similarly, the x2 bar will be equal to 5 plus 5 plus 3 plus 7 divided by 4 equal to 5, and similarly x3 bar will be equal to 5 plus 4 plus 3 plus 4 divided by 4 equal to 4. And after this, the step 2 is that we have to work out the mean of the sample means, that is x bar is equal to x1 bar plus x2 bar plus x3 bar plus dot 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 plus xk bar divided by number of samples, that is represented by k. So here x1 bar we have already calculated as 6, x2 bar we have already calculated as 5, and x3 bar is we have already calculated as 4. And since there are 3 samples, it will be 6 plus 5 plus 3 it will be 6 plus 5 plus 4 divided by the number of samples, that is equal to 3, which will be equal to finally 5. Okay, then the step number 3 is to calculate sum of squares per variance between the samples, that is represented by ss between, which is equal to n1 into x1 bar minus x bar whole square plus n2 x2 bar minus x bar whole square plus n3 x3 bar minus x bar whole square plus dot 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 plus nk into xk bar minus x bar whole square. And since we have already calculated x1 bar, x2 bar and x3 bar, and there are 3 samples here, and we have also calculated in the previous step the x bar, so we can put the values like this, that is n1 is the number of items in the first sample, that will be equal to 4 into 6 minus 5 square plus 4 into 5 minus 5 square and 4 into 4 minus 5 square is equal to 4 plus 0 plus 4 is equal to 8. Then the step number 4 is to calculate mean square between samples, that is ms between, which will be equal to ss between divided by k minus 1, where k stands for the number of samples, which will be equal to 8 divided by 3 minus 1. And why it is 8 divided by 3 minus 1? Because in the previous step we have already calculated that the ss between will be equal to 8 and k is equal to 3, since there are 3 samples, so it will be the final result of ms between will be equal to 4. And the step number 5 is to calculate sum of squares for variance within the samples, that is represented by ss within, which will be equal to summation of x1i minus x1 bar square plus summation of x2i minus x2 bar square plus summation x3i minus x3 bar square plus dot 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 summation xki minus xk bar square. So here I represents the columns, and the column wise individual values we will take, and what we will do is that we will subtract the average value of each column from individual values, that is 6 minus 6 whole square plus 7 minus 6 whole square plus 3 minus 6 whole square plus 8 minus 6 whole square. Why we have subtracted 6 here? Because the arithmetic mean of the first column was found to be 6, and individual values from individual values of the first column, the arithmetic mean of the first column has been deducted, and the square values have been taken, and then it has been added here. And similarly here in the for the second column, it will be 5 minus 5 whole square plus 5 minus 5 whole square plus 5 minus 5 whole square plus 7 minus 5 whole square. Then similarly for the third column, it will be 5 minus 4 whole square plus 4 minus 4 whole square plus 3 minus 4 whole square plus 4 minus 4 whole square, and finally it will become 0 plus 1 plus 9 plus 4 plus 0 plus 0 plus 4 plus 4 plus 1 plus 0 plus 1 plus 0 is equal to 14 plus 8 plus 2 is equal to 24. Then step number 6, we have to calculate the mean square within samples, that is ms within. Ms within will be equal to SS within divided by n minus k, and here n stands for the total number of items in all the samples, that is n1 n2 plus n2 plus n3 plus up to nk. But we have got 3 samples here, and in each of the samples there are 4 items, so ultimately the total number of items in all the samples will be equal to 4 plus 4 plus 4 equal to 12, so n will be equal to 12. And since we have calculated SS within will be is equal to 24 in the previous step, so it will be 24 divided by 12 minus 3, since there are 3 samples, so k will be equal to 3, and the final result will be 2.67, that is the MS within we have calculated. Then the next step is to calculate the sum of squares for total variance, that is represented by SS total, which will be equal to SS between plus SS within, which will be equal to 8 plus 24. SS between we have calculated in the previous step as 8, and SS within we have calculated as 24, so it will be equal to 32. And then the step number 8 is to calculate the degrees of freedom. The df between is equal to k minus 1, and since k is equal to 3, so it will be 3 minus 1 is equal to 2, and df within will be equal to n minus k, since n is equal to 12 and k is equal to 3, so it will be equal to 9, and df total will be equal to df between plus df within, which will be equal to 2 plus 9 is equal to 11. Then the step number 9 is to compute the F ratio. F ratio will be equal to MS between divided by MS within. Since MS between we have calculated as 4, and MS within is equal to 2.67 we have computed, so it will be equal to 4 divided by 2.67, which is ultimately result in a value to it will be a value of 1.5. Then step number 10. In the step number 10, we have to compute the we have to construct the one-way ANOVA table. In one-way ANOVA table, you can see here that there are various columns, and source of variation has been given in the first column, and the source of variations are within samples and between samples. Then in the second column, the SS has been given, and then the third column DF has been given, and the fourth column MS has been given, and fifth column F ratio has been given, and the sixth column critical value of F from table has been given. So we have put all the values which we have computed in the previous steps in the blank columns of the one-way ANOVA table, and F ratio is equal to 1.5, and critical value we have taken from the table, and this we have taken it from the F table. Why it is F table? Because when we compute ANOVA, we assume that it will follow F distribution. So here there are 2 degrees of freedom which we have taken, that is 2 and 9, and finally it is 0 at 0.05 level of significance. The table value of F will be equal to 4.26, and if we will put it in a graph, then we can see that here it is the acceptance region here, and rejection region has been given. The critical value of F, since it is 4.26, suppose it will be in the x-axis in this place, then obviously the value, computed value of F ratio, that is F, that is called F ratio, will be somewhere like here, somewhere here it will lie. So it is in the acceptance region, so that is why we have to accept the null hypothesis, and we have to conclude that since the calculated value of F is less than the table value at 0.05 level of significance, we accept the null hypothesis and conclude that there is no significance difference in impact of different types of ad contents. So friends, we have already discussed how one-way ANOVA is computed, how one-way ANOVA table is constructed, and how interpretations are done by use of one-way ANOVA table. Now we will try to know how one-way ANOVA as a statistical analysis is performed by use of analysis tool pack of this MS Excel. So friends, this is the example in our hand, and in this example the table here has been given like this, and in this table column wise there are 3 columns, and the add content A, add content B, add content C, and these 3 columns basically are representing the data on the 3 samples. I will copy it, the whole table I am copying it, and then I will go to a fresh Excel sheet, and in this Excel sheet I am copying it, and I have pasted it here like this. Okay, now this table has the same table has come from the this Word format to the Excel format, and now what I will do, I have clicked data and I have clicked data analysis. Here I will choose ANOVA single factor, that is one way ANOVA. Okay, then I clicked wake. Okay, and now it is asking the input range. So input range it has been given in the table, and I have to select the input range here. So in order to select it, what I will do there are 2 different options. One thing that I can select the labels also, and for that I have to click there. Then I have to choose a alpha value, that is the level of significance, either 0.05 or 0.10. In this case it is 0.05, and column wise or row wise the values of the sample will be there. It is in column wise in this present case. So I have selected the range, and here it is saying that where do you want the output. So I have, it is in the new worksheet. I have found the output in the new worksheet, and this is the Excel output, friends. And you just see this Excel output. It is just the same table which we have calculated manually, and with a few clicks only you can get the one-way ANOVA table through MS Excel, friends. So that is how you can calculate the ANOVA table, one-way ANOVA table. So friends, in today's class we have already discussed about how the one-way ANOVA is computed, how one-way ANOVA table is constructed, and how the interpretations are done on the basis of one-way ANOVA table. And we have additionally understood how one-way ANOVA as a statistical analysis is performed by the use of analysis tool pack of MS Excel. So that is what is it for today, friends. Thank you very much.